All right, so here's 8.7 z-score, okay? The z-score is a measure of position. So we learned about measures of central tendency. We learned about measures of dispersion, which is range and variance and standard deviation. And now we are learning about a measure of position, which is the z-score. The z-score lets you know how many standard deviation you are above or below the mean. So it's a measure that lets you know in relationship to the mean, how do you position? How does your score is positioned in relation to the mean? So if we have this little formula right here, we can find out exactly what your z-score is for your tests in relation to the mean, the population mean. So what does each of these symbols here represent? Z represents your position in relation to the mean. X represents your actual score. Okay, if we're talking about your ACT score, your SAT score, your whatever actual value is, that is what X represents. The variable mu is a Greek letter, and that represents the mean of the population. That's the mean of the population. And then this little nice cute little whistle, the sigma, the Greek letter sigma, is the standard deviation. So that's what those three symbols mean. Whenever I have four unknown values, z, x, mu, and standard and sigma, whenever I have these four unknown values, whenever you give me three of them, I can figure out for the third one, okay? So give me three values, I can figure out for the fourth one. So I don't always, it's not going to always be like they're going to give you the x, the mu, and the sigma, and they ask you for the z value. Sometimes they'll give you the z score, they might give you the standard deviation, and that might give you the mean, and they ask you to solve for x. So you have to have algebra skills to be able to solve for whatever it is not given. I like to always read the problem and line up my information before I can figure out what I need to solve for. Let's do some easy examples first, okay? Let's just first, number one, it says, an exam produced grades within a mean of score of 74. So let's go ahead and identify the information we have in front of us. So the mean score of 74.2, mu is 74.2. The standard deviation is 11.5, so that's my sigma, 11.5. Find the z-score. So what I don't have is the z-score. Round it to the nearest hundredth for each of the following test scores. So you're giving me the actual test score, okay? So let's go ahead and do just letter C, because all of the other ones will be exactly the same. So letter C gives me the actual test score of 79. The actual test score of 79. So that is my X value. So the X value is 79. All I have to do is use my little z-score formula. So the z-score tells me I grab the X value of 79, subtract the mu, which is 74.2, and divide by the standard deviation of 11.5. So let's do that calculation nicely on a calculator. 79 minus 74.2, it's 4.8, and then you divide by 11.5, and you get 0.4. So let me tell you exactly what you get. You get 0.417399, whatever. So but they asked me to round to the nearest hundredth. That's usually what we need for z-score is 2 decimal places. So I would round the z-score to 0.42. Okay, and if you ever go into statistics, you will notice that we always try to keep the z-scores to 2 decimal places. Okay, it's because of the 7, I turned the 1 into a 2, and it's approximately 0.42. What that tells me, okay, what the z-score tells me is that in relation to the average, just like you learned in empirical rule, in relation to the mean of 74.2, this person with a score of 79 is not quite one whole standard deviation above the mean. It is about a little bit less than half. Okay, if this was half of standard deviation, that person is a little bit about half, less than half above the mean. That's what the z-score right here tells me, that is your position in relation to the average score of everyone that took that test. Okay, so that is your position in relation to the average. You could say proudly, I was a little bit above the average. It's not super high above the average, but that's what it means. That's your position right there. Okay, so that's what the z-score tells you. I am pretty sure you can go ahead and solve the rest of these other z-scores. Try to understand what it means. Is it above the average? Is it below the average? How far? What is the position in relation to the average? Okay, the mean. Now let's take a look at number 2, because number 2, it says, let me use the bottom portion of this paper. Number 2 says, a sample of textbooks has a mean price of $120. So let's go ahead, and the mean is 120. The standard deviation is $20. So I'm just gathering up information here as I read. Find the textbook price that corresponds to each z-score. So I don't have the actual price of the textbook, but I have a z-score. So as I told you, they don't always give you the actual price and ask for a z-score. Sometimes they give you the z-score and ask for the actual price. So the z-score, I'm going to do letter B here. And the z-score they're giving us is 1.2. 1.2 is the actual z-score. How do we manipulate the formula? It is up to you. You can manipulate the formula before you plug things in, or you can plug things in and then solve it from there. So the formula tells me the z-score, 1.2, z equals the x value, which I don't have, minus the mu of 120 divided by the standard deviation of 20. Now this becomes a simple algebra problem for us to solve. Okay, how do I isolate for the actual value to solve for x? Well, if you multiply both sides by 20, so this side will undo the multiplication and the division here, and then you can go ahead and do 20 times 1.2, and you get 2.4 equals my x minus 120. And then you go ahead and just, I'm sorry, not 2.4, is 24, sorry, is 24, okay? And then you can go ahead and add the 120, and you get that x equals 144, okay? So you just solved for the actual score of 144. So they gave us the z, they gave us the mu, and they gave us the sigma, the standard deviation. We just had to solve for x. Okay? All right. So I showed you both ways. It depends on how you need to manipulate the formula. Always gather the information so you know what is it that you need to figure it out. Now let's go ahead and do something different. Let's go ahead and do number 3 here, because it is not a calculational, it is an understanding question. What does it mean to say that an x value of 152 has a z-score or a standard score of 1.5? Well, if I have an average, okay, and the average is right here in the middle, and my score of 152 tells me that my z position, my standard score, is 1.5, so I have 1 standard deviation, 2 standard deviation, 3 standard deviation. That tells me that I am 1.5 above the mean. So I am right here as a position, my score of 150, this is 1.5 z-score. That tells me that my score of 152 is it is 1.5 above the mean, okay? That means I am above 1.5 above the mean. If you think of empirical rule, if this was a standard, if it was normally distributed, we could say I am above 50 plus 13 I'm sorry, 50 plus 34, I'm above 84% of the students that took a test, okay? I am 1.5 standard deviation above the mean. That's what it tells me, okay? This 1.5 is telling me my position in relation to the mean. All right, so let's go ahead and do another problem. Let me see, have I selected something different here? Let's do number 6, okay? Number 6 is the last one I'll do for standard deviation, and you should be able to solve the rest. I'm sorry, yeah, for a z-score, not for standard deviation. A married couple are employed by the same company. That's mistake number 1 already. A husband works in a department for which the mean, so let's go ahead and separate the husband and the wife information, okay? So the husband works in a department for which the mean hourly rate is $12.80. So the mean is 12.80. And the standard deviation is 1.20. The standard deviation is 1.20. His wife is employed in a department where the mean rate is $13.50. So the mean for her is $13.50. With a standard deviation of 180. Standard deviation of 180. Relative to their departments, which is better paid if the husband earns, actually the husband earns, so the actual value the husband earns is $14.60, and the wife actual earning is $15.75 per hour. Explain your answer with a mathematical proof and a justification. Assume the distribution for both rates is normal, okay? So we have a normal distribution, and let's go ahead and find out the position of this husband in relation to the mean, and let's find the position of the wife. The nice thing about z-score is that it standardized both of their values. These are totally different values, totally different averages, but z-score puts them in the same relation to the mean, okay? If I had the mean here, I would, because it's normally distributed, I would be able to put both of them in the same line here and find their position. Let's go ahead and use the z-score to find the husband's position first. So that would be 14.60 minus the mu, which is 12.80, divided by 1.20. And that would give me his position as z-score. Let's go ahead and do hers. Z-score for hers would be the 15.75 minus 1350 divided by the standard deviation of 180. So let's go ahead and solve that with a calculator here. Let me do the husband first. 14.60 minus 12.80, and then I'm going to divide by 1.20. I got his z-score to be 1.5, okay? That's the husband's z-score, 1.5 above the average. Now let's find out the position for the wife. Okay, so I have 15.75 minus 13.5, and then let's divide by 1.80. And her z-score is 1.25. Okay, so I have the z-score for the wife and the z-score for the husband. And as you can see, just based on the z-score, he is higher above the average paid than she is. So this would be 1 standard deviation, 2 standard deviation, 3 standard deviation. So let me go ahead and place the husband. The husband is 1.5. Here's the husband z-score position of 1.5. The wife is slightly below at 1.25. So the wife is right here at 1.25, 1.25. So in relation to position above the mean, the husband is better paid. He's a little higher than the average than his wife, okay? Not by much, but he is a little bit higher than the wife. So this is enough explanation. All the work I put in here, let me zoom out a little bit. If you have all this work right there, this is the husband, and this is the wife, and that tells me who is higher above the average in terms of pay, and that would be the husband. Explain your answer with mathematical proof. That means with values and with justification, and this is enough for you to show who is being better paid. Okay, so I hope you understand how to use the z-score, what the z-score represents in terms of position, and how to use the z-score formula. You're going to have a little bit of algebra skills if you need to solve for an unknown value besides the z-score. Okay, good luck, and ask me for help if you need any.